Hi there and welcome to the channel. It's good to be with you here. In today's video, I thought we should sit down and discuss Pythagoras Theorem. And Pythagoras Theorem is a theorem which, as far as I'm concerned, can very accurately be described as ubiquitous in terms of its prevalence in both mathematics and in physics. Because in whichever direction you take in mathematics or physics, you are bound to bump into Pythagoras Theorem. And so it makes a lot of sense to know it right from the beginning. Now, what is Pythagoras Theorem? Well, Pythagoras Theorem is a theorem that deals with right-angled triangles. What is a right-angled triangle? Well, a right-angled triangle is a triangle with one of its sides equal to 90 degrees. Let me slow down. Okay, the triangle that I do have on the board right now is labeled A, B, C. And I've labeled the angle at A theta. And there is a right angle. This is the sign for a right angle. There is a right angle at B. And so the triangle ABC is a right angled triangle. Now, the sides of a right angled triangle are given special names in relation to this angle theta there. Now, the side which is adjacent to the angle theta is called the adjacent side. I've abbreviated it ADJ. And the side which is directly opposite the angle theta is called the opposite side, and I've just abbreviated it OPP. The remaining side, which is the longest side of the right angled triangle, is called the hypotenuse, and I've just abbreviated it HYP. Now, what does Pythagoras theorem say? Well, Pythagoras theorem says HYP all squared. I hope I'm not blocking anything here. HYP squared is equal to ADJ squared plus OPP squared. What does this mean? This means that if you square the length of this side AC, what you get is the square of the side BC plus the square of the side AB. So square of this is equal to square of this plus square of that. Let's take a simple and nice example. Supposing we are given a triangle. Let me try and make it straight here. Okay, so here is our triangle. Okay, let's label it A, B, C. Okay, how you label it is really neither here nor there. You can call this side A or B or whatever it is, but the right angle triangle is here, because remember, Pythagoras theorem only works when our triangle is a right angled triangle. If it's not, we have to use something else. So supposing we are given that this side here is 3 units of length, and this side here is 4 units of length. The question is, what is the length of that side? Well, Pythagoras theorem says HYP squared is equal to ADJ squared plus OPP squared. Now, what are we given? We are given the adjacent side, which is ADJ. We are also given the opposite side. What we are not given is the hypotenuse. So if we plug in our numbers into Pythagoras theorem, we will get HYP squared is equal to ADJ, the adjacent side, is of length 4. So we have 4 squared here, and that one there is 3, which should be squared, and that gives us 16 plus 9, which is equal to 25. Now, the hypotenuse squared is equal to 25. So therefore, the hypotenuse itself is equal to the square root of 25, which is equal to 5. You see how we used Pythagoras theorem. We were given this side and this side. Well, we didn't get that side. So we quote our theorem and then we plug in the given numbers and we get that one there. It's very, very important before you solve your problem to quote the theorem, because in examinations, once you have quoted the theorem, you have shown the examiner that you know the principles that are supposed to be used in this problem. You may, in some way, get your arithmetic wrong, miscalculate something, but most of the marks are here where you have quoted the theorem or the principle, whatever the case may be. Let's take another example. Okay, now supposing we are given this side as, let's say it's 30, and we're given this side it's 3. The question is, what is that side? Of course, this side from our triangle here is the opposite side. We are given the adjacent side and the hypotenuse. Once again, we've quote our theorem. So HYP all squared is equal to A dj, the adjacent side squared, plus OPP all squared. What do we know? HYP is 30, so we have 30 all squared. What is ADJ? It's equal to 3 all squared. What is this one here? We don't know. So it's OPP all squared. Okay, we can, of course, multiply this. What is 30 squared? It's 900. I hope I'm right. 30 squared is equal to 900. And of course, 3 squared is 9 plus OPP all squared. Now, we can take the 9 to the other side. Excuse me if I can use this part of the board. So we can now say 900 is equal to 9 plus our OPP squared. Remember, it's squared. So taking 9 to the other side, what is 900 minus 9? It's 892. It's equal to OPP all squared. So therefore, the square root of 892, I'm taking the square roots of both sides, is now equal to our OPP. Of course, you can put that in a calculator and get the actual answer. But that's your Pythagoras theorem. It's a simple and straightforward theorem to use, provided you know your relationship between this and that and that. Remember, everything is squared. This is squared, this is squared, and this is squared. In our next video, we are going to look at other trigonometrical formulas that can be used to solve triangle, the cosine formula, the sine formula, etc., etc. And we'll discover that somehow the cosine formula itself has some relationship with Pythagoras theorem. Till we see you then, bye-bye and take care.